Okay, welcome back. Yeah, I made a really simple mistake. This should, of course, also be point position. There we go. Because the velocity has no values right now, so if I would use that as the position, it would basically be almost zero. Yeah, I also added the facet node, but I don't think I actually do want it there. Okay. So yeah, this was more of the shape I was going for. But we'll add some more noises on top. So first, let's add another unified static. And we're actually going to use the normal from here. Position. Wait. No, sorry. That's not what I meant. We just want to use the position from here. And we'll add another displace from normal. And in this case, I want to use the normal from the other side. And we'll use the amount from here. And then add that there. Okay, so right now it's just the same noise type twice, which is not really what we want. Instead, I would like to go for a whirly noise. And I'm going to reduce the scale a bit more. Let's say 2.2. This one is 0.5. So now we have the large scale, but we also want to add some more micro noise. So I'm just going to copy paste this again. And in this case, we'll just use a simplex or Berlin. It doesn't really matter too much, but I'll go with simplex. And again, I'll use the position here. And because of how this noise works, I'm not going to displace, but instead I'm going to add. So to make sure that that works, I need to output a 3D noise and input a 3D. So now you can see that the color of noise changes from blue to green. It's quite subtle, but there you go. So I could just add it like this, and that should work. But yeah, now it adds the entire Berlin to the entire thing. Yeah, because the Berlin noise only generates values between 0 and 1, and we want to make the noise in both directions. So let's do that using a fit VOP, sorry. So fit range. I'm going to input this, and it's going to be from 0 to 1 to wait. 0 to -1. That makes sense. No, that doesn't really make too much sense. I might actually have made a mistake in my example file. So I'm just going to say -1, -1, and then the max is going to be still 1. Okay. So now we want to add a scaling to our noise. And this is something we want to control. So let's add a multiply. We'll put that there. We'll put that there and promote parameter. And we actually want to make the scale much smaller than 1. There we go. So now we at least have one control to do this. And I think we probably want to tweak a little bit the frequency of this noise. Yeah, so let's put that on 5. Yeah, so now we have a more rough rock. And now we can tweak the scale. So yeah, don't set it too high because then it will self-intersect. But a 0.1 should be fine. There we go. Okay, and then there's one more thing we want to add, which is actually we want a different rock for every time frame. So let's do that. And in that case, we only really want to affect the big shape. So I'm just going to add a parameter. And I'm going to call it seed with small s and big S here. And I'm going to go from float to vector. And just put them all in here. No, in there. And then use that as the offset. So now we should actually have, oh wait, no. So now if we set the seed, we have different rocks. But if we move in like increments of 1, we get different enough shapes. So I'm now just going to replace this with $F. And now if you use the arrow keys, you can generate different types of rocks. Okay. I also would like to use the new poly reduce. You can use the old one in 16 and earlier, but the 16.5 one is much better. So I'm just going to keep 50%. And in this case, I think that's all I would need to do. Like you could say preserve quads. Yeah, but in this case, that doesn't really help too much because the quads basically need to be kept too much to preserve the shape. So I'm just going to go to triangles and yeah, put on, let's say 50. That seems fine. Let's put facets up and a color. And let's make it like really gray brown. So something like that. Yes, okay. So now we just need to build the placement system. Let's move these out of the way a little bit. So yeah, we're going to reuse some of the technology we made in the first set of the tutorial. I'm just going to copy paste some of that code. But yeah, going to have a bit more microcontrol than last time if you followed the first part. So what I'm going to do is work with group wrangles. Group expression, sorry, which is basically a point wrangle for groups. Okay, so if I would say the water group would be 0.1, that doesn't seem to do anything. It's interesting. Yes, because we're still in primitives. There we go. But instead of that, we can actually also reuse the biomes that we generated. I think we should still have them. Yes. So I could also say underscore biome name included. Yes. So that still works as well. If you want to review what all the names were, you can check everything under here. And if you followed both the tutorials, you can also add more all the way up above this. But for this tutorial, we should not need any extra so far. So yes. Let's just check more of these groups. So if we say open, it should be more or less the opposite of included. Yeah, generally is. There we go. Yeah. So say we would want to scatter trees on this group. We probably want to get a slight border extra. Otherwise, the chance that it will scatter right on the edge is really low. So let's add something for that. So in this case, well, let's rename it open group. So open here, we're going to union with existing. So it's going to add points to the group. It's going to include by edges. Use edge depth. Oh, not Control B. Control V. Control Shift click removes the expression again. I'm going to set it to 2. Set this to points. Oh yeah, disable that. Because otherwise it will just add all the points to the group. So now there should be a slight edge increase. You know what? Let's call this a different thing. So we still have the original and the new group. So open group and open group expanded. Let's promote from points to primitives, open group. Oh wait, and we can just come on, add reload. Come on, there we go. Open group expanded. From points to. Okay. And now you could say last everything that's not in the expanded group. There we go. Delete non-selected. So you could just add a scatter node here. And that would work. But yeah, we're going to go a little bit more advanced than that, because we also want to check the actual final distance to the edge. Because yeah, we expanded the group, but we don't actually want points right on the edge like here. So what we can do is add a group. You should already have made this preset, which will group all the points on the edges. Just to go over it again and share points, disable all these and enable these. Or alternatively, we can make an optimized version of this because we're still using a 2D grid with no extra edges. So we can just say group underscore and shared equals length point prims of the current point number, and if that is smaller than 3, that should also be in the group. So it won't actually highlight, although if I do that it might. No, that doesn't. Okay. But unshared should be the same number, so 932. That's not the same. Okay, let's review if that's okay. Combine and shared. So if we scroll out really far, what's the difference? Okay, see some difference here. Ah, yes, okay, that makes sense. Because here there's actually extra edges. How did we fix that last time? Yeah, because right now this point has 1, 2, 3 vertices, and we only want to keep 2. For the neighbor count of the current PT num is bigger than 4. No, that does not do what we want. And neighbor prims integer. There we go. so we don't have to do the math twice. Gotta do something. That seems about right. So 0.29, 0.29. So that seems about right. Yeah, okay. So now they're equal. Because if it's on the inside of a corner, the amount of neighboring primitives does not change, but the amount of connections does change. So as long as it's not completely surrounded by primitives, it should be an unshared point. So that should be fine. Okay. With unshared. And now what we can do is just use a find shortest path. And we'll go from any start to any end, and we won't output any paths. And we'll use the unshared group. So now if I would use a color, yeah, and let's rename this to distance. Let's put it on point and ramp from attribute distance. And let's, yeah, now you can actually see that we created a fall off from the edge, which we can use for all kinds of stuff. You can also do this using a attribute transfer, but if you do that, sometimes there might be some interference between groups. So if you have two edges quite close to each other, it might start to override the effect from each other. And in this case, it will just take the minimum, which is what we want. So now we could just use a scatter here. I'm going to put it on manual. I'm going to save as well. Distance placement. Because whenever you put a scatter node on density scale, the default density scale is often way too high, so it will basically slow down your PC to a crawl. So you have to make sure that this value is sufficiently small. And in my case, 0.05 should be okay. And if you want to make sure that nothing cooks while you're doing these changes, you can put it on manual mode, of course. So let's do that. And now I'm just going to, for demonstrational purposes, add a copy to point sub. And I'm going to just copy the rocks on the terrain. Okay. So right now we have a really uninteresting way of scattering the rocks. So one thing we can actually do is make the rocks bigger the further away they are from the edge. So let's do that using the wrangle. Because we use a scatter, the distance attribute will be kept. So we're going to use that. So float min dist is going to be chf filter dist, and if the distance is smaller than min dist, we are going to remove the point. And we're going to return because we don't want to execute any extra code. So now it's, well, it won't do anything just yet because we haven't set out the, oh yeah, there's actually one really easy way to speed up this process, because we do not really care about the primitives. We just care about the object system as a whole. So we can just use backend instance. So this will create backed instances of our rocks before copying them on the terrain. So now the update speed should be a bit higher. So let's set up that. And for our filter dist, we're going to use 20. So yeah, now it removed all these points right next to the edge. And we're going to add a scale, point scale equals fit distance from min dist to chf max scale dist, and we're going to put the range between min scale and max scale. There we go. So now everything should be 0 because these values don't exist yet. So let's make sure that that happens. Minimum scale is going to be 10, the maximum scale is going to be 20. Yes, and let's set the filter dist to 1 actually, and the max scale is 20. So if I would increase this range, yeah, the rocks would become smaller. So now let's re-enable that. Okay, so maybe this is not really. Let's put it to 1. Let's do 10. Yeah, so now you can see that the further away from the edge the rocks are, the larger the rocks will become. Okay, so right now they're still actually rotated all the same way, but we'll fix that in a moment. Okay, so let's actually start with our actual placement system. So we're going to use all these examples to actually build it, but I think we'll do that in the next part of this tutorial. But first off, let's actually output our geometry. So let's add a drop output driver. Yes, there we go. And did I? No, I did not. Okay. So actually going to use render frame range in this case. We go to hold Ctrl Shift and click here to remove the expression. And for our trees, we're just going to render between 0 and 0. and we're going to save this in our instance folder. That's geo instance. Let's remove hip name, but keep OS and underscore frame. There we go. So now it will save this to rock geometry 1, but that's not what we want. We actually want to call it something more intelligently. So if we rename the node, there we go. Also, generally, my personal preference is to start with frame 0. But you also might just start with frame 1. You might need to update the code a little bit in the next part of the tutorial if you do that. I'm not entirely sure. Okay, so that should work. Let's do the same for this one. We'll just call it pine. And we'll do the same for this one, and we'll call it rock or cliff. Call it rock, cliff. Even better. Okay. For the rocks, it actually does matter because we actually create different rocks for our frames. So I'm just going to create 12 different rocks, or 13 actually. So 0 till up to and including 12. And that should output 30 different rocks. Okay. So let's see you back in the next part of the tutorial, where we will actually place all the instances from these files.